This tutorial will explain how to 3D model this part to help prepare you for the Certified SolidWorks Associate Exam. This video is separated into 3 parts. Dimensions and relations have been changed from the original practice CSWA exam. Part 1. To create this 3D model, I'm going to select a part file and then select OK. Then I'm going to ensure the Sketch tab is selected because I'm going to begin a sketch. And I'm going to select the front plane. After selecting the front plane, I'm going to select to draw a rectangle, and this is going to be the perimeter of the model that I'm creating. So I'm going to smart dimension the rectangle to 87 by 60. Both of those are millimeters. Next, I'm going to double check that I actually have the part file set to MMGS because that's what the drawing calls for. I'm selecting the line segment, and I'm going to start at the top right just because those lines actually intersect my boundary that I've created. And I'm just sketching out the overall idea of the model on the right side. And then I'm going to go through and smart dimension each one of those lines to the actual drawing dimensions. So when I'm creating an angle, I need to pay attention to the actual drawing and select the proper line. So I'm selecting the vertical line first and then the line that's set at a diagonal to set it at 45 degrees. Notice I did make a mistake here and I set that distance at 7 when you can see in the orthographic drawing in the top right that it should be set to 5. I do correct this later in the video when I double check my measurements before moving to creating this actual 3D object. So when setting up the diagonal line segment to 29 millimeters, notice the horizontal line at the bottom kind of flips sides. So it's really easy, just grab the point and move it back over to the correct position to move forward. Here I'm selecting a point as a reference, and I don't want that point to sit on or intersect another point because it'll get locked in position, so I moved it slightly above that center point on the diagonal line. So I'm about to get to the arc portion here, the first arc portion that I need to draw, and there are many different ways to create arcs, but I'm going to show you a couple in this video. And for this arc, I'm actually going to use a circle. And the reason I'm using a circle to create the arc is because the center of that circle is 19 millimeters above the base. And so this is just an easier way for me to create the arc and lock the center of that circle in place at 19 millimeters. Here, once I have that circle in place, I'm actually extending that baseline out to the circle so I know that it's actually intersecting with the circle. Next, I'm drawing the horizontal line that comes after the 2 arcs, and I want to set that dimension to 19 millimeters above the base of the sketch as well. Because I already have 19 millimeters set from the base to the center of the circle, it's a redundancy. So I'm going to select to make this dimension driven, and it's going to gray out once I deselect from the dimension. Now I'm going to create the second arc, and I'm going to use the tangent arc because in the drawing it shows that there's a tangency between the horizontal line and the arc. And now I'm going to smart dimension that arc to the correct radius. And once I've done that, you'll notice it gets a little funky. The arc overlays kind of intersects past the circle. And so the way to correct that is to select the circle and the arc and then select a tangent relation. And so that pops it into place. So if you look at the drawing, you'll notice there's a tangent relation between the horizontal line and the arc, and then the arc and the circle. Right here, my computer's just spazzing out a little bit, but once I zoom out, everything's okay. Now I'm going to go in and use the power trim tool. I get rid of the rest of the circle so that you just see the arc. And down at the bottom, you'll notice that there's a little bit of circle segment left. That's related to the dimension. That's not an actual line, so it's not going to affect your 3D model at all. I forgot to save the part at the beginning of this of me modeling, so just really quick going in there and saving that so I don't lose any of the data here. So now I'm moving on to drawing the other linear lines on the left side of the sketch. And then I'm going to go back in there and smart dimension those to the proper dimensions. And being that when I drew the line segment, it snapped to 45 degrees, so this is just making the dimension driven again. Not a big deal, it'll gray out when I deselect. So this is where it gets a little bit tricky. I'm going to draw this diagonal line first, and then I'm going to set it to 10 degrees. Notice you can also set your angles on the left side in the property manager. I set it to 350 degrees because you have to think about 360 minus 10 degrees is 350 degrees. And then I'm going to smart dimension that just to make sure that it is set at 10 degrees. Next, I'm selecting a tangent arc again, and I'm going to go off of that 10-degree line that I created and snap it to the horizontal line at the top. And then I'm just setting the radius to 19. Here I'm just going back and adding in a few of the dimensions that I missed. And I'm just going back through and double checking all of the dimensions to the orthographic drawing in the top right. And here is when I realized that I set that to 7 millimeters instead of 5 millimeters. So now I'm going in, I'm adding that circle, and I put the radius at 7, but when I smart dimension, it asks for the diameter. And so the diameter is 14, so I just okay that there. And now I'm just adding the positioning dimensions so that the center of the circle is 14 millimeters up from the bottom and 14 millimeters right from the left side. Now I'm going to extrude the model to 60 millimeters. And you can see the hole went all the way through. And next I'm setting the material so I can check the mass properties like you would in the actual exam. And I'm going to set the material to steel, 1020 steel to be exact. One thing you want to check for is the mass density, and you want to make sure that it's actually the same as on the exam. The outline of the exam gives you certain properties that you should check for. So then I go to evaluate mass properties and check the mass. And so I'm at 1462.49 grams. And so this would be the answer to one of the questions if it asks what the mass in grams of your part after you complete it. Many times on the CSWA exams, they will ask you to modify the part you just created in SolidWorks. So that just means going in and changing some selected dimensions, typically their overall dimensions, to different dimensions that they have set. And this is just showing you how to change those overall dimensions so you can see how the part file might actually fluctuate in size. And once you've done that, it may tell you to change the material. Most of the time it doesn't. It just tells you to change those selected dimensions. And then you can go into mass properties and check what those check what the overall mass of the part is in grams, see that it has changed. If it doesn't change your numbers, you can select recalculate in the mass properties menu, and it should update. This concludes part 1. Part 2. To begin this next part, I'm going to start a sketch. And when I start a sketch, SolidWorks asks me to select a plane, a planar surface, or an edge to start the sketch on. So I'm going to select the front face because I'm drawing the circle In the top right view, you can see the orthographic drawing of the circle that I'm going to create. And I'm in the front view just so I know it's flat and on the correct plane. And so I selected the circle tool, and I'm dimensioning the circle to 10 millimeters in diameter. Next, I'm going to use the Smart Dimension tool to position the circle. And I'm positioning the circle 15 millimeters from the top down and 15 millimeters from the right to the left. Next, I'm selecting the Features tab and Extruded Cut, and I want that hole to cut all the way through. It's set at blind in one direction at 60 millimeters, so it's good to go. It cuts all the way through. The next orthographic drawing shows the top view of this finalized part, and I need to kind of scoop out that area there. So I'm going to create a plane using reference geometry, and I'm going to select the back of the model. And since this is fully defined, this plane is, I'm going to flip it so where it's actually intersecting the model. And then I do want that dimension to be 10 millimeters. Notice in the orthographic drawing at the top right that it's 10 millimeters, and the cut part is 24 millimeters. For the next portion, I'm going to start a sketch on the plane that I just created. And I'm going to select a point and drop that point on the diagonal line, because I want the circle to intersect that point exactly 36 millimeters from the top. Next, I'm selecting a center line, also known as a construction line. So I have an actual line that I can start the center of my circle on that lines up with the far right edge of the model. Once I have the circle drawn, I want to move that circle so that it intersects that point that I created on the diagonal line. So I'm going to select Move Entities, and for entities to move, I'm going to select the circle. And then for my start point, I'm just going to select an area that is close to that point, and then move it to there, make sure that the point lights up orange, and so now I know that it intersects that point. My last step here is to smart dimension the circle so that I am sure that it is 82 millimeters. The next step here is to go to Features and Extruded Cut, and I want to cut the circle portion out of the part, but I only want it to be 24 millimeters. So I select Blind Direction 1 and I type in 24 millimeters. This has cut the part exactly where I wanted to cut it at exactly the correct dimensions. Next, I've moved to the top view and I want to take out this area here. And so I'm going to start a sketch from the top plane. And to do that, when I select Start a Sketch, since I want to start it from the top plane, I'm going to drop down the design tree and select the top plane from there. Since the area that I want to cut out from the model is a rectangular cut, I just grab the rectangle tool and smart dimension the height of the rectangle to 19 millimeters. Then I smart dimension the distance between the right end of the model to the right end of the rectangle to 62 millimeters. Now I need to do the extruded cut feature to cut through the model. So I do want it to cut through, so I need to flip the direction of the cut. Flip side to cut is not where you flip it. It's actually here in this little button next to blind, and I want to select through all because I want it to go through the entire model. Since I no longer need the plane that I created, I'm actually going to make it invisible so it's not obstructing my view. So if I just right click the plane, I can select the eyeball to hide it. If I ever want to bring it back, I can right click plane 1 and select the eyeball to show it again. The last thing that I need to cut for this model is the tail here. And you can see from the orthographic in the top right that it cuts into the part at 19 millimeters. Next, I'm going to draw a sketch on the front surface of the model. And I'm selecting the line tool and I'm snapping it right off of the bottom ledge there, making sure it's straight. Doesn't matter what the length of the line is, but I do need to smart dimension it from the bottom of the model and ensure that it's exactly 19 millimeters. Since I'm just cutting to a certain depth in the model, I'm just making a rough trapezoid type shape. No need for it to be perfect because I just need it to cut right through the model. I've selected extruded cut, and I do want a certain depth. I want it to go 19 millimeters into the model. Now I'm just double checking everything, making sure that the tail cutout is even and that everything looks okay with the model. So for this model, I'm going to leave the material set at the 1020 steel and go to evaluate mass properties and check the mass in grams of this model. This concludes part 2. Part 3. For the last part of this tutorial, I'm going to cut this area out in 2 parts. I'm going to start a sketch on that front surface. So I select sketch, select the front surface, and then I'm going to select the front surface again and select offset entities. The offset needs to be set at 1 millimeter but reversed so that those lines are on the interior of the model. Next, I'm going to go to the Features tab and select Extruded Cut, and then I'm going to cut into the model a certain distance. I'm setting that distance at 10 millimeters, and so that's going to leave me a 1 millimeter border around the entire compartment that's cut out. Next, I'm going to create a sketch on the surface that I just cut out, and that's going to give me the remainder of the cut for the compartment. So I'm creating a sketch and I'm selecting that cutout compartment surface, the front surface. Now I'm going to select that surface again and then select Convert Entities, and that converts that boundary into line segments. By flipping the model around, I can select the curve that I need to offset from to be able to finish this sketch. And I'm going to offset that curve at 1 millimeter, and it's going in the correct direction. And then this is going to show the curve that I need, so then I can go in and trim away any of the excess lines, and then power trim away the lines from the border that I no longer need. From here, I have a closed contour, so I can go into Features, and then Extruded Cut, and I'm going to cut into this model 25 millimeters. So I've already cut into it 10, and then the extra 25 is going to give me the full 35 millimeter cut that I need to match the orthographic drawing in the top right. Now I'm just double checking the model to make sure everything looks correct. I'm going to leave the material at 1020 steel and then go to Evaluate Mass Properties and check to see what the mass of the entire part is. This concludes part 3 and is the end of the tutorial.